HVAC Temp Rise formula for measuring airflow CFM gives you a fast, accurate check of system performance by converting temperature rise and sensible heat into cubic feet per minute. Measure supply and return temperatures at the same duct locations. Use a calibrated digital thermometer and average 3 steady readings over 2 to 3 minutes. Calculate temperature rise as supply minus return, then apply the formula CFM equals sensible heat in Btuh divided by 1.08 times temperature rise in degrees Fahrenheit, where sensible heat equals the system's sensible cooling or heating load. Or, for field checks, use rated Btuh output on the furnace or heat strip minus any known losses. Always correct Btuh for fuel type and combustion efficiency when using furnace nameplate numbers. When measuring heat pumps in heating mode, use compressor and outdoor ambient correction charts from manufacturer data to estimate sensible Btuh because total capacity includes latent and defrost impacts. For air conditioning checks, measure indoor wet bulb and dry bulb to compute enthalpy and sensible heat ratio if latent loads may bias the simple sensible heat method. Use a manometer or Pitot traverse to confirm duct velocity if CFM discrepancies exceed 10%, RFAB. A single point velocity can mislead in uneven flow profiles. Perform a minimum of 5 traverse points across the duct and calculate the area weighted average. For short-run systems with variable speed blowers, lock the blower to a rated speed where possible or note the fan curve point. Variable frequency operation changes static pressure and shifts CFM nonlinearly. Account for filter condition, coil loading, and external static pressure (IX+). Measure external static across the coil and filter and compare to manufacturer allowable values. A pressure rise beyond the allowable indicates reduced CFM even if temperature rise looks acceptable. When using temperature rise for smaller furnaces under 30,000 Btuh, watch resolution limits of your thermometer and the small numerator in the formula. Use higher precision instruments or longer averaging to reduce noise. Always document ambient conditions, instrumentation serial numbers, and the exact measurement locations on ductwork so the check is repeatable and defensible for warranty or code inspection. One of the top mistakes is poor measurement technique causing inaccurate CFM readings. Common errors include single-point temperature sampling and not averaging, incorrect thermometer placement, and ignoring duct stratification, MIS. Fix this by using 3 to 5 steady readings, sampling at least 2 duct depths, and performing area-weighted traverses with a pitot or vane meter. Include instrument calibration records. One of the biggest issues is using nameplate Btuh without correcting for combustion efficiency or system operating mode, which leads to inflated CFM USA. Fix it by measuring actual sensible output, heat exchanger exit temperature, rise times actual measured airflow when possible, or apply combustion efficiency correction factors from manufacturer literature. One of the most overlooked problems is variable speed blower behavior and external static pressure effects that change CFM despite stable temperature rise, USHAs. Fix by locking blower speed for test conditions where possible, measure external static pressure across the coil and filter, and compare to the blower curve or manufacturer allowable static to determine true delivered CFM. BigHomeProjects.com lists trusted local HVAC contractors and supplies project-ready listings that help homeowners find certified pros for airflow testing and system tuning. The directory also gives contractors a platform to win local work by showcasing certifications, specialties like temp rise testing, and client reviews.